If you want to access, she's recording it. If you want to access previous presentations, and actually I've had quite a few requests for the walleye and Lee Kernan, and those haven't been posted on the scan. We've even created a scan code here. There's these sheets around the back. There's 20 of them. So if you want to take one with you, then all you got to do is scan the code and you get right to the playlist. And then after all the ones that are loaded for this year, we'll have 24 different videos on there dating back to 2021. So all real good stuff. And now you can jump. Yeah.
Recognizing the right input. Plug it and plug it back in.
Hey,
How's it going?
it was going awesome. Stuff's happening. We're moving around on the screen anyway.
That means there's feed to it.
Yeah, my one worry is like there's no green light on the projector. Normally there should be a light on, right? Okay. I can't see it though. Like usually it's that big one. All right.
I would think it'd be
I don't know. I mean, I don't want to reboot my machine. really, because Zoom's all hooked up. We'd lose everybody, and it was working. But it's just like order doesn't matter sometimes.
How we gonna do it?
I can talk. It's not gonna be terribly interesting. I mean, and I could even start talking if you guys want to keep trying to figure it out. I was trying to think of that. I don't know. Like, I'm willing to. The problem is if we go off my computer, we lose the Zoom link. Because we could try that other one, and I could save it on a flash drive and move it over. But I don't understand why that would be the problem since it was working. Yeah, but I'd try and think this one. See, it says, oh yeah, she's messing with the DVD inputs. There it is. There it is.
Oh, team go. Hey. Dan. And I think I was going through Laura Connie is joining the Zoom right now. I'm from the library. We appreciate their partnership as well.
No, this isn't working.
Here's where I was going to talk about the sheet that I already did. For those on Zoom, if you want to take a scan at the code right there, you'll have access to the playlist of all the previous presentations that have been made since 2021. So, or use the link on the bottom there, but if you got your camera there, you can get it quicker with the scan code. And also those on Zoom, if you could please, turn off your screen and your microphone. That helps save some bandwidth here, so things work a little bit better. And that would be great. But again, thank you for coming. Boy, this is a great turnout. We really appreciate it. So back to here. So tonight we're going to have Dr. Dan Eiserman here from the Wisconsin Cooperative Fishery Research Unit of the United States Geological Service, survey, that works in partnership with the state, which is in this case DNR, and the university. And that co-op unit is very unique that way. Actually, I'm a product of that co-op unit. I got my master's at Stevens Point, so I know how valuable it is. But the nice thing is actually this partnership, they can focus on applied research that is meaningful to the DNR that they can use to help manage fisheries. And I think Dan's going to talk a little bit more about that. But we're fortunate to have Dr. Eiserman available for tonight's presentation because in the past, the co-op unit program was on the federal chopping block in this past year. And in addition to that, some of the two major research labs that affect Great Lakes work, the Great Lakes Science Center in Ann Arbor and the Upper Midwest Environmental Sciences Center in La Crosse, were also zeroed out in the original budget of the president. But thankfully, to Congress, with strong support of their Great Lakes Task Force, it has been restored, or at least they're okay this year. So we're very happy about that. And it all said, at least in this case, because as you'll hear, the research and science they're doing is so important. Science and research does matter in Wisconsin. And Dr. Eiserman and the research unit has been an extremely valuable asset for the fisheries in Green Bay. Actually, this is his fourth time presenting the Fish Sales Lecture Series. That's the most of all our presenters. Karen Murchie is right behind, only one behind, but we have these people back again because they have so much to say. And back in 2021, his first presentation, which was on where fish wander in Green Bay, tracking the movements of walleye and whitefish, that recording on the playlist has been hit about 1,300 times. So that's another record. He has a record for appearances, but he also has a record for hits on the playlist. So the next highest one was like 211. So it kind of blew everybody away. And I don't know if that's just someone that kept hitting it to watch it over again.
I pay my kids well.
And the acoustic tags that Dan used in the smallmouth bass research that he's presenting on tonight is a part of the Great Lakes Acoustic Telemetry Observation System. Oh, did I go wrong? Yeah, there we go. And I just want to show you, most people don't know all this is going on. So I want to give you an idea of that. There's actually been 13, since about the mid 2000s when the Ramos started, there's been 13 projects focused on Green Bay. And some are ongoing, some have already done. But most of them are on whitefish. That's where most of the questions have been. But you can see it's a whole variety of species. And so there's been 13 projects. Dr. Eisenman has been either the primary investigator or a collaborator on 10 of them. So he's got a wealth of information, and he is so important to developing and increasing our knowledge of what happens on Green Bay. So with that, I think I'll just turn it over to you and let's get started.
All right. Thanks everybody for coming. Sorry about the technical difficulties. They seem to follow me wherever I go. Those 1,000 hits are from my kids on positive. So I did want to, Mark did a pretty good job. I just wanted to talk a little bit more about our program. So I'm a federal employee. I'm stationed at the University of Wisconsin-Stevens Point. And this is a unique partnership program within the federal government. And we work with our partners, which includes Wisconsin DNR, Michigan DNR. You'll see some Ohio DNR stuff in here. And then also to conduct this research, but one of our other goals is to train graduate students. So we're looking for that next generation of fish biologists. So not only are we trying to do research that's relevant, not just to the DNR, but also to stakeholders. We work a lot with anglers and guides and commercial fishers and people whose livelihoods are tied to the resource, or it's their favorite thing to go fish for bass or go fish for muskie. We work a lot with, we'll talk about Wisconsin Smallmouth Bass Alliance, muskie clubs, walleyes for tomorrow, like a whole bunch of different stakeholder groups. And then also just to provide technical assistance when needed when training. And a lot of this telemetry, a lot of those projects where I'm involved in some way, a lot of it's like on the technical assistance side of things because we've been doing it for quite a while. Oh, I forgot. This part doesn't work. All right. So we are going to talk about smallmouth bass today. And this is a project that really originated through that partnership with the DNR and primarily Scott, who's here tonight, talking about questions that the agency had regarding just the management of the species and how we should approach it from a spatial aspect. Some of that's related to tournaments. I know a lot of venues are moving away from the classic haul all the fish to one place and do a weigh-in, but at the time that was still the norm. But also just at a larger scale, how do we manage these groups of fish? And this project was funded by the Great Lakes Fishery Commission. So that is sort of one of the things that we do as a unit. We identify the issues, and then there are funding sources that we can go out and secure funding for to do the research. So it isn't all Wisconsin DNR or Michigan DNR trying to fund these projects to study the species. And we'll talk about most of the rest of these groups as we roll along. All right, so we're going to really focus in on Green Bay. Part of this project is happening on Lake Erie as well, but I'm not going to talk much about that tonight. And the thing that we do know is that thousands of smallmouth bass spawn in many, many different locations within the Great Lakes, and that includes Green Bay. Dozens and dozens of places where you could go find bass on a bed at some time during the year. And we know from some previous genetic work that they're probably not fully isolated units. Like they always go to the same spot and all the fish always go there because over time they would all look the same genetically if that was going on and they never strayed. And this is just some genetic results here. And you can see like here there's a lot of this blue color, but they're not all that blue color, right? And so there's some mixing going on. Maybe there's some unique units, but what we're trying to figure out is at what scale should we say this is a bass stock or a population that we want to manage? And then there's another stock or population over here that we wanted to manage separately because they're not really connected. They're not exchanging fish. And that includes in Green Bay, the spawning locations include tributaries, harbors like Sawyer Harbor, Egg Eagle, we'll talk about tonight, islands, shorelines, the flats. You know, you could rattle off, again, dozens of places, and we can't go study them all. But we're really going to focus in on some of them and try to figure out what do these bass do and how should I lay out like boundaries if I'm thinking about managing this species. And why are we doing that? The smallmouth bass fishery in Green Bay and specifically along Door County is a pretty important part of the overall tourism scheme in the area. Lots and lots of people come to this area to fish for smallmouth bass and walleyes and muskies and a whole bunch of other things. But bass are a pretty important part of that. So the things that were the sort of our rationale for doing this when we pitched the idea was, again, what's the appropriate scale for smallmouth management? And these are sort of some of the kind of questions we'd ask, like, should we manage the whole Door Peninsula as one unit? Or is like each harbor or each group of bass its own discrete entity? And if something happens to it, we're not going to get bass from somewhere else because that was the group of fish that were there. And then we're going to talk a lot about rivers. Are these populations in the rivers, are they residents or are they transients? They're actually bay fish that just come into the river to spawn and then they leave. How much of that is going on? Does each one of these rivers represent like a distinct run of bass? Do we need to treat them separately? And then something that's, again, sort of related to that tournament approach to weigh-ins, does displacement of fish that might occur in a tournament disrupt like those natural boundaries that we see out on the landscape? And so these were the questions that we asked. We wanted to know, do bass have high sight fidelity for spawning? Do they always come back to the same place to spawn every single year? Or do they kind of get confused and go over here one year and then over here the next year? And they're not that loyal. So everybody always thinks of salmon as like the gold standard of this. And gold salmon are really, really loyal. Most other fish are not that loyal. And it doesn't take very many fish to go from one place to the next to make it so they're not genetically distinct anymore. And they're really just one group of fish. And then we want to know, what do they do after they spawn? Do they go swim all over Green Bay? Do they mix up? Are they all mixed up? Or do they kind of just hang around right where we tagged them and they're again like this isolated or semi-isolated group of fish? We talked about the rivers. Do we have river run fish and river resident fish? We wanted to figure that out. And then we wanted to look at, do the genetics we see out there match what we see behavior wise? If these fish aren't mixing, are they distinct genetically too? And that would mean they're really not mixing over very long periods. And then what happens when we move fish around? All right, so these are the places that we went. We went to 4 rivers: the Econo, Peshtigo, Menominee, and Cedar. I'm going to say they're on the west shore. That's how I'm going to refer to it the rest of the evening. And then 3 harbors or bays: Sawyer, Egg, and Eagle. And there's dozens of other places that we could have gone, but we had to base our decisions on coordinating with the DNR to get us fish. It's always way easier for us to just show up and tag fish. If I've got to catch the fish and tag the fish, it's going to be a really long day. So we like when people will just give us the fish to tag. And also just information, like Scott had previous population information for these harbors. They're encompassed by the Creel survey, a bunch of other factors that we wanted to include. And we also wanted to make sure they were far enough apart that when we did this displacement experiment, it was least interesting within like a tournament framework. All right, so what did we do? We relied on the DNR to capture us bass. We went to all 7 locations during May 2023, and we tagged 30 fish at each location. And one of those was the Cedar River, and so we worked with Troy Zorn and the Michigan DNR to get our fish out of that river. So that's 210 bass swimming out there with one of these transmitters. This is it right here. So it's a little wider than a quarter. It's got about a 3-year battery life. And what this tag is doing is sending out a signal, we'll say roughly every 2 minutes or so. And it's sending that out, and we'll talk about how we find out where the fish is here in a minute. And then in May of 2024, we went back out and tagged another 60 fish, and these were our displacement fish. And I'll tell you about the boat ride they got to take here shortly. All right. So this is we do the surgery. This is our surgery setup here. So we're actually flipping the fish over. We're using a TENS unit, which is just a low dose of electricity. The same kind of thing your doctor might prescribe to you for a back spasm or something like that. And we put the transmitter in. They also get an external tag, but it's brown. So on the walleyes and whitefish, we have an orange tag because a lot of times, or some of the time, they're going to get harvested. And it's $100 reward. And if we can get the transmitter back, we can reuse it. What we did not want to do is encourage people to harvest smallmouth bass just because they could get $100 reward. So I suspect that people catch these fish and they don't even know that the fish is tagged some of the time because the tag is brown. And then this is just one of our contestants in Eagle Harbor right after the surgery. So a lot of times we would knock fish out with a chemical anesthesia, but then the fish is like really groggy and it has to have this recovery period. Once you take the pads off the fish, it's ready to go. It's like back to normal. I'm not saying it doesn't know something kind of rough happened to it, but it's ready to swim. And so this is just a fish immediately. You can see the loop tag on the back there as it swims off. And then we always tell it to go do something exciting when we send them off. Sometimes you tell them to go one way or the other. Don't go left, don't go right. Then scattered throughout Green Bay, every one of these little yellow dots is a listening station. So if that fish swims by there, that tag gets registered with a date and time stamp on it. We know the fish was there. I cannot tell you exactly where the fish is. With this size tag, I can tell you in open water, it's within about a quarter mile of that listening station. On our bigger, like sturgeon, muskie tags, we can hear them a mile away. On a good day, you might be able to hear them a mile and a half away. But so we don't have a pinpoint location. We just know kind of where in the grid the fish are or in what river the fish are. And you can see, like in the tributaries, you'll see all the little yellow dots. So if a fish goes in the river, we usually have a pretty good idea it's in the river. You'll see around Sturgeon Bay, we've got quite a few receivers, Larson's Reef. A lot of these are focused on whitefish. We got some lines along the shore, so when we displace the fish, we can see them cross the lines on their way back to where we moved them from. The shipping canal. And then this out here is not accurate. I just wanted to let you know that we have 90 receivers on the lake side of the door. So if a fish were to leave, and these aren't really for smallmouth, they're really for the whitefish we're tagging up in Big Bay to knock. But if it left, we would know about it if it went on the lake side. So that's how we hear it. We have to go get these things every year to get the data on them. It isn't magic satellite downloading yet. Most of them, we can go out to it and communicate with the receiver, and it activates a worm gear and it floats up to the surface and we can go get it. Download the data, send it back down. Who really helps us with that is the Fish and Wildlife Service Green Bay office. They tend a lot of our receivers. We tend some. And then that GLaDOS group that Mark mentioned earlier, they send a boat over and do like the Michigan side because it's a pretty long haul for us. So it's this collaborative effort. DNR maintains a lot of receivers in the tributaries on the west shore. Actually, most of those receivers over here we don't touch anymore, and the DNR takes care of them. Then all that data comes to us. And when I say all that data, we're talking like 20 million lines of data. If you went to a place like a business and asked their data manager to help you with this and said, well, we have 21 million lines of data, they wouldn't know what to do. They've never handled a data set that big. Excel only holds 1,900,000 some lines of data. So it all gets fed into GLaDOS, the portal, the data portal. And then Nancy Nate gets it all organized, and it takes weeks. And I mean, it's a lot of data. And this is coming from all the Great Lakes. So it's easily tens of millions of fish detections. And then eventually we get a data output. So we finished downloading our receivers in like November, December this year. And we're just to the point now where we can start to do things with last year's data. So it's a pretty big load to try to get through it all. All right. So I'll say for bass, we're probably somewhere between 7 million and 10 million detections for those 210 tags that we put out there in 2023. So the first thing that we wanted to find out is how loyal are they to their spawning locations? And again, I'm just reminding you where those are in case you forgot, because I did a lot of talking between then and there. We've got our 4 rivers and our 3 harbors where we tag the fish. So this number over here on the left-hand side is what percentage of the fish went back to that spawning location 1 year later in 2024. And so the Menominee fish, they're pretty loyal, 86% of them. The rest of them are not very loyal. The Econo River fish are not very loyal. Now, these rivers, the Menominee, Econo, and Peshtigo, they're located like pretty close to one another. And so some of these bass are just switching rivers. They haven't like wandered off the map. They're just not in the same river. But some are not in a river, and they might be out in the bay. And we're still trying to sort that out. And this is just how many of them we knew were around a year later, our best guess at the time. So remember, we tagged 30, and we'd expect we'd lose 20 to 25% a year just through mortality. And most people are stunned when I say that. But for walleye and bass, you're losing about a quarter of your fish population in most populations every year. Natural fishing mortality, whatever the case might be. If not, they'd be piled up on the bank and we'd be kicking them off the boat ramp to launch the boat. So they do die. Even if they live to their high teens, they're dying at a fairly high clip. So these numbers are in line with what I would expect to see. I keep thinking this thing works. And then these are the harbors. So the one thing is you'll notice that the harbor numbers are remember the Menominee was like 86%. The harbor fish are a lot more loyal on average. Most of them are coming back to that. If we tagged them in Sawyer Harbor, they're coming back to Sawyer Harbor. And they're not straying a whole lot. So I thought I was going to have this data for this year. I started sifting through it, and it's kind of the same trend. So it would be 2 years later in 2025, basically the same thing. The rivers were less loyal than the harbors were. We obviously have fewer fish coming back because we're 2 years down the road. The other thing that I think we're seeing from the data is that the river fish have a higher mortality rate than the harbor fish. I don't know why that is, if that's natural mortality or if that's harvest mortality, but there seems to be a little bit of a sign that they may be dying at a higher rate than our harbor fish. And we'll know more about that as we go on. So what do we conclude here? On average, about 70% of them return to their spawning locations. This is pretty similar to what we've seen for walleyes in the tributaries. It's a little lower, like Fox River walleye are a little more loyal than this. It's not as loyal as salmon, for sure. That's for sure. So that means there's enough fish exchanging from place to place that already my presumption is they're not going to be very genetically distinct. There's too much straying going on from place to place. The harbor fish seem to be more loyal than the river fish. And eventually what we will have when we get all of our data is each fish will get a spawning history. So I just classified one here. If it was in the Menominee one year, the Peshtigo the next, and then the Menominee, that's what we'll classify it as. And we'll be able to see, well, they're not loyal to the Menominee, but they're kind of just staying in that cluster of rivers. The one thing is the cedar, which I didn't, I'm going to back up. I just forget what we had there. Yes, whoops. It wasn't that loyal, which is kind of interesting when we look at some of the movement data in a little bit. So 64%, because you're going to see that's kind of interesting relative to some of the other things I'm going to show you. All right, and then eventually we'll run a model and we'll figure out is the level of loyalty related to where we tag the fish, the sex of the fish, or the length of the fish. So I'm going to ask a quiz question. Who do you think would be more loyal, a male bass or a female bass? Why? Why do you think that?
Nesting in similar nests as each year, so they just have to remake the nest.
So you have the right reason, but who makes the nest?
Yeah.
The boy, yeah. What we're seeing is it's the females wander a little bit. Maybe even within the same spawning season, they're in more than one place. The males, once they set up shop, that's where they're going to be. And they seem to be a little bit more loyal at this point. That could change. All right. So then now we want to know, what do they do after they spawn? Where do they go? And so if you watch all these little dots move around, these are river fish getting detected. They can't swim across land, even though the model says they can. It's a direct, it just does it by like line of sight. So it didn't fly across the shore to get there. So what I can't really slow this down for you really well, but you'll notice like all these river fish kind of come out and they're out in front of those rivers on that west shore. And we even watch like even some of the sea, like look at this slowpoke coming down even some of the cedar fish come down this way. But if I could slow it down for you, what you would see is if I hit the spawning window, they're mostly sorted out again with a few strayers because we already know that. But the colors kind of sort themselves out. But this is the kind of information we get from all those millions of detections. You'll also know you don't see any of them coming over here. Yeah, they really do not cross. Like every once in a while, I think one comes over here by Little Sturgeon, says, man, it's kind of a rough neighborhood, and it goes back over there. But they don't really cross the bay. So we're already getting an inkling from this, right? That these fish over here might not be the same as these fish over here. So this is their maximum distance that they moved away from where we tagged them. And for the metrically challenged, which includes me, I've included the 5 mile mark and the 10 mile mark. So this is the average maximum distance for each of our rivers. The Peshtigo fish like to go really far away, which is interesting because the whitefish that we've tagged in the Peshtigo River also seem to like to go really far away compared to the other rivers. But mostly under 5 miles from where we tagged them. Your longest distances, like this fish went pretty far, but 10 miles is this line right here. You're getting a few fish that'll go 10 miles away from where we tagged them. All right, here comes another video. Here's your harbor fish. So some of them look like they're walking right past some of your houses, I bet. The one thing that is interesting to me is that the Sawyer and the eagle or egg fish, they seem to mix quite a bit outside of spawning. However, you don't see a lot of the eagle harbor fish. They do. They come down to egg, but you don't see a lot of them come all the way down to Sturgeon Bay. Yeah, but there's a lot of mixing. And again, if I could slow it down, when we get to spawning, they're sorted out, and you might see an orange one down here and a purple one over here, but not a lot of them. And you also have to realize, like, we do have receivers in like Little Sturgeon, but there's so many little places that these bass could go spawn. They might not be back in Sawyer Harbor, but they could be somewhere else that's not that far away, and we wouldn't really know about it. If they came into Sturgeon Bay, we're going to know they're in Sturgeon Bay. I think we have one receiver in sand, maybe. There's like one in a couple of the other smaller bays. But anyway, all right. So how far did they go? Here again's your 5 mile mark, and there's your 10 mile mark. The harbor fish, for the most part, are staying within about 5 miles of where we tagged them, if you want to think of it that way. With the few strayers that go pretty far away. But the thing from those animations is on either side in the summertime, you would have no idea what kind of fish that you caught. It could have been an egg harbor fish, or it could have been a Sawyer harbor fish. Now, it might be more likely to be a Sawyer harbor fish if you're closer to Sawyer harbor, but it could still be an egg harbor fish. And if you were out in front of the Menominee, Econo, Peshtigo rivers, they could be from any of the three. Heck, it could even be a Cedar River fish, but it'd be very unlikely that that would be the case based on what we saw. All right, so besides the Peshtigo, who seems to be the itinerant like river for fish, they like to travel. They stay within about 5 miles of the tagging location. The river and harbor fish, west shore and east shore, don't seem to mix very much. There's really limited mixing during spawning. Again, if I could slow down that, and I was working on trying to get you some bubble plots made today, but some other stuff happened that I had to deal with. The river fish are pretty mixed along that west shore during the summer, and at least the egg and Sawyer fish are pretty mixed, like out in front of Sturgeon Bay. Maybe the eagle fish, not so much. There's not as many eagle fish coming down. And so that's important to know, like moving an eagle fish from Eagle Harbor down to Sturgeon Bay, that may not be something that fish has ever done before. Moving an egg harbor fish down to Sawyer Harbor, that fish may have been there before. And I think you're going to see that'll play out a little bit when we get to the displacement. Eventually, we'll do a bunch of statistical analyses instead of me just pointing at dashed lines. And then we're going to create home range polygons for each individual fish. And we'll be able to look at the overlap of those polygons to see how much do egg harbor fish overlap with Sawyer harbor fish or Eagle harbor fish with egg harbor fish. All right. River residents versus transients. So we had to come up with some rules here because there's a lot of nuances to what the fish did. A full-time resident is a fish, we tagged it, and the only place we ever heard it was in the river. Never left the Menominee River. A partial resident was in the river most of the time, but a lot of these fish leave in the winter. They're there the whole summer. They come in the, like when things, not quite now, it's still a little too cold, but they might come in before spawning, they're there. But when the water temperature drops off again, they kind of dump out into the bay, but then they come back. But they're there like 75% of the days during the year. And then a transient is there during spawning, but the fish leaves. And a lot of times, some of them don't even come back to the same river to spawn the next year. So we were calling that a transient. They go out in the bay somewhere, hang out, and then they come back, but maybe not to where we tagged them. So when you look at these plots, these are our rivers, and the gray blocks here are the transients. So most of the fish that are in these rivers during the spawning period, say late April into May or into even June, they're not from the river. They're bay fish most of the year. They come in and then they leave. So pretty small numbers of true resident fish in the lower segments of that river. And that was kind of interesting to us. We didn't know the answer to this question. This is basically what walleyes do in the tributaries to Green Bay, most of the fish, right? They come in, they're there to spawn, and then they leave. And we've been able to do some really interesting things with that data. So this is walleye data here. And what you're looking at is when the females enter the river, when the males enter the river, water temperature, and then actually these dashed lines are when the seasonal harvest regulation kicks in. And when you see the white dots, that's when you hit the 50% of the walleyes that are coming are in the river. And then on the backside, that's when you're back down to 50%. So in this case, using that telemetry data, I can show you that the peak number of walleye in the Fox and Menominee rivers always falls within that period where they have additional protection. Sometimes there's a few fish in early, sometimes there is a few fish in late. But eventually we will do this with that bass data too, to look at what are the cues that bring these fish into the river? Why are they coming in when they do? And how long are they there? All right, now we're going to talk genetics. I am not an expert on genetics. We did some stuff in our lab. And this stuff allows us to like basically assign fish to genetic clusters. And then we did some more stuff and it said there's 4 clusters. 5's too many, 3's not enough. It's a simple statistical analysis. So each fish of those 210 fish gets assigned a probability of being in one of the clusters. So this fish right here had a 95% probability it was in cluster 3. We're going to say it's from cluster 3. If it was over 80%, we said it's from that cluster. But then you get what we call an admixture, and I'm a farm kid, I'd call this a hybrid. It's a mixture of different clusters. We don't have these sorted out yet all the way, but I'm going to show you what we have seen just at a very coarse level, and it's preliminary, and my genetics folks probably wouldn't like me to be this firm on it. So here's our harbor fish. You'll notice none of them fall within V1, V2, or V3. The pure ones, the 80%ers, are all in V4, that cluster. So there's no river, any of them that are assigning like strict. And then here's how many are a mix of some kind. And we got to fit, we're still working on like, what are these mixtures and what do they mean? So there could be some river genetics in these admixtures. So this aligns with, well, we'll continue here. The Cedar River is kind of like all by itself. And the Cedar River fish aren't in the Menominee, Peshtigo, and Econo rivers when spawning happens. They might go the other way and be in the Ford and the Escanaba, but I don't know if we have detections of them there. I'd have to look. I didn't think about looking at that because we do have receivers in those rivers. And then, whoops. The Menominee, Econo, and Peshtigo are mostly in this V3. There's a V1. Look at the Menominee, though. Tons of admixtures. So we got to figure out what do those admixtures look like? Like, where's that coming from? But at least at a course level, it kind of seems like they're following the boundary of the West Shore fish and the East or the Door Peninsula fish are kind of different. At least some of them.
What's N?
That's the number of fish. Sorry. And I keep hitting that button perfectly every time. Okay. So yeah, rivers are largely separate from the harbors, it looks like. Cedar seems to be maybe a little different than the other rivers. The harbors seem to be mostly part of one cluster. And the admixtures are going to likely show us there is some crossover that I'm glossing over tonight because I don't know the answer yet. All right. Last major thing, the displacement experiment. Okay, so this was kind of fun. But what we didn't do is simulate a tournament. So most of the previous studies that have done this, they would go out and get their fish out of somebody's live well. But what I didn't want to learn is that some of these fish might die because they were in a live well all day. I have no idea. It might not have been a lot of them. What I wanted to know, or what we wanted to know, is how good are they at it under perfect conditions? What is their innate ability to find their way back? Not after they've gone. I don't know. See, if I show up at the tournament and a guy's got fish in a live well, I just have no idea what those fish went through during the day, where they came from, how long they've been in there. And they might be in really, really good shape, which most of them usually are, but I just don't know the history of the fish. These fish I know the history of because Scott and Derek handed them to me out of a fike net. I know exactly what they went through that morning, and then we put them on these blue tanks, and Jack Tong gave us a ride on the back. And we tagged them on the way to Sawyer Harbor. So we took them from Eagle and we took them from Egg and we drove them down here to Sawyer Harbor and let them go. So about 27 miles and about 15 miles. And so the fish were in really good shape. We had ice on them, pumping air. It was pre-spawn. They had just kind of come in. Maybe they were starting to think about making a nest, but I don't think any eggs were in a nest yet. And then did they make it back? So we tagged them on the 21st of May and the 24th of May in 2024. This is how many made it back. They were detected in the place we caught them by October 1st. 73% of them made it back to Eagle Harbor. And Egg was 83%. And here's just a distribution of how many days it took them to get back there. And the mean was about 3 weeks. So one thing is to keep in mind is that they probably were not where they should have been for spawning that year. So we did disrupt that. The interesting question is, were they back there the next year? And so I didn't have time to put this all together, but it looks like their fidelity is about 10% lower than the fish that we just tagged in those bays in 2023. But it's within 10% of what we would expect normally. So even though we moved them, they missed spawning where they should be. I mean, some of them might have made it back, but they probably spawned somewhere else. But a lot of them were back there for the following spawn, but not as many as we would have expected given what we saw with the fish we didn't move. So there was a little bit of a drop off there. And that's unofficial as of right now, but a little tidbit that I was working through yesterday. All right. So most of them didn't make it back after we moved them to their spawning location. They did find their way back usually in less than a month. So under ideal conditions, these fish can largely find their way back. And why is that? Well, I think it's because in this area and at those distances, a lot of those fish have been there before. Like, remember all the eagle, they probably were like, wait a minute, this is the lighthouse off of Sherwood Point or whatever. How did I end up here? You know, some people ask us why we didn't put them on a truck and haul them on land. I don't know how a bass finds its way back. And I didn't want to like drive it on that disrupt it. Maybe it's something to do with swimming. At least they were on the water course. I mean, it's always amazing to me that because these aren't big, giant sturgeon or anything. They're little, like 18-inch fish and that's a fairly big one. And they find their way back. So what we're going to try to do is figure out how many of them were they back where they should be. And I just gave you that little nugget. Like, for the most part, it looks like they were. And then is return rate, all these other things related again to sex, total length, and how far away we moved them. So we're going to download the receivers one more time. The tags die this spring, right? So our last pieces of information are going to come. Like in May, these tags are going to start, not the displacement fish, they'll go one more year, but we're coming to the end. So this summer, we'll get our full set of data. And what I should have said at the beginning is Celia Schwartz is our grad student that's working on this project. You saw a picture of her, right? Oh. There, that's her right in the middle. So she's the one that I'm just here, showing off. She's the one that's put all this information together and is working on the new data that we have in hand. All right, I don't want to go too far here. All right. So even though they got the brown tags on them, people do catch them. I checked with Dan today. We've had 38 encounters. 2 of them have been caught twice, and 4 have been harvested, and 3 of those are from the Cedar River. So harvest does happen, and that could be some of the mortality that we're seeing in some of the fish. And then sometimes we love when people call us up with the fish. If we got anything else real important to do, we'll like drop everything and go figure out which fish is this and where did we tag it, because it's really interesting. So this was Landon, him and his dad reported this fish. So we tagged it back in that 2023 tagging, and then they caught it in May 2025. So it had only grown not even an inch, maybe about an inch. So pretty slow once they get that big. And another cool thing, I was actually up here fishing this spring in Sawyer Harbor, and I was tying a lure onto my rod, and I looked over the side of the boat, and I saw one of our fish swim by. The rock tag. It was in a big school of. There was like 3 or 4 of them. I was like, "Holy cow! What are the odds of that?" So kind of neat when they show up. All right, so a lot of people to thank. I mentioned most of these folks. We have had some support from the folks that organized the Sturgeon Bay Open. The Wisconsin Smallmouth Bass Alliance always writes us a letter of support when we put our proposals in for funding, and I just went down and talked to them a couple months ago. Again, the Michigan folks were involved with the Cedar. You're seeing the Ohio emblem because that's the Lake Erie connection. They tagged some river fish as well. So thanks for showing up. That's what I've got for you. And yeah, it's a pretty cool gig if you can get it like on these days.
That's why we're very lucky to have a co-op program and people like Jan. Question? Got one right here.
Yeah, I was wondering how this correlates to the food source. Any idea how you can find out when they fall? Where they go?
So the question is, could we figure out like how this is related to prey, like the availability of prey? I think that would require some kind of understanding of prey densities, like where, I can tell you where they are. I can grid out the bay by my receivers, and I can tell you at least they're in this part of the bay within, a certain distance of the receivers. But we don't know, is there a lot of gobies there? Is there a lot of alewives there? Is that why they're there? That would require some and possibly that data is available through like hydroacoustic, but gobies would not be. That's something that we don't really sample to the point that we can estimate like for the bay, like the density of gobies in all these different areas.
Would you just assume that that's where the fish are, is where the gobies are?
I don't know. I guess, I don't know if you've looked at diets of bass during the course of the year. I know that they eat a lot of gobies, but I'm not saying they exclusively eat them. I would think at times alewives are probably important to them because they'll go out. The one thing that you don't see though is them out in the middle of the bay. They're pretty tight. I won't say tight to shore. Our receivers are pretty far offshore. It's just they're not going way out there. And if I showed you movements of like walleye and whitefish, you would see some fish that were like out there in the middle of the bay. But yeah, it's something that's kind of beyond our ability to tell. We could easily do like water temp and habitat, but prey would be a little tricky.
How far up north do they typically, how far up river do they go, say for instance, on the west side of those 3 rivers?
A lot of them all the way up. That doesn't mean they're going to stay there, but they are distributed like throughout it. So the Akanto River fish that we tag they were down by that campground that's toward the lower end of it. So they were not all the way up, but the Menominee is really short, and they're not going up and hanging out in the tailwater like a sturgeon. I'm just saying they're going to the like upper third of it usually. If you know the Menominee, the lower third of it is pretty slow, and there's not a lot of good spawning habitat there. But they're getting up there by where the railroad trestle is and Stevenson Island and like up in that area. I think the Peshtigo and the Akano, it's much longer to the dam, right? They're probably distributed more. But it's not a question we've really asked of the data. It doesn't, but we could ask that, like, how far up are they?
Are they territorial?
So we know a lot about them from smaller lakes where you can measure it, and when they're on the nest, they're territorial. So I've been here before and showed you the videos of the nesting stuff. We know in smaller lakes they often nest within like 50 yards of where they nested the year before, and then they're going to defend the nest. But I think outside of nesting, not that I know of, I don't think they're like actively chasing each other off at that point. I got a hand right.
For spawning temperature, is it different for the bass to spawn from a river at a certain temperature compared into the harbors? For instance, it'd be like 50 or whatever degrees from one to another, or is it pretty much about the same in temp from one location to another between bay and river?
So we don't, from the telemetry, we can't tell exactly when they spawn. We just know that they're in the place during that window of time. So I could look at, are they in the rivers earlier than they are in the harbors or something along those lines? But that would be akin to that plot I showed you for the walleyes. Like when we get to that point, I could answer your question. But I'm going to say it's going to overlap. So when we were doing the nesting work, some of the like nesting egg laying, there's eggs in the nest windows are like a month long. So there's probably like a lot of overlap between, it would be, maybe you could say on average one was earlier than the other, but there's probably some river fish that hang over and overlap with some harbor fish or vice versa, however it goes. But yeah, we just haven't looked at that information. I don't know if you have any sense of if they're in the rivers like before they're in the harbors. Yeah. I want to say they're in the rivers before, because like the way that warming works, that would be true. But in these harbors, like they're spawning so shallow a lot of times, like that water is pretty dang warm fast, so it might offset the river stuff. Best I can do. I wasn't ready for that one.
Yeah, thanks. Great. My question relates to those rivers on the west side of the bay and the difference between the Cedar River, which is undammed, and the other three, which are dammed. I can't remember why you showed the portion of transient versus residue fish. If there was a big difference between Three Rivers and Cedar River.
Yeah.
I was just wondering if, because of the distance they have and the Cedar River travel greater than the two dams.
Yeah. So we had Michigan DNR. We tried to collect fish like further upriver than just really down by the mouth of the Cedar, and then there's a creek that runs in right there, and they got some fish up in it, but it like joins the Cedar, like not, it's just right above where it dumps into the bay. So like we went up when we were putting out receivers all the way up to like the next, what I would call a riffle, that at the time was hard for us to get past in our boat. But yeah, I mean, and that's something that we wonder about is, are there fish that are like in these rivers and they're between our receivers and we're calling them unavailable because we don't know where they are. So Dan Demkowski, who helps with all of this stuff, and one of our students, they floated the Econo and Peshtigo to see if they could hear any of our missing fish, and they didn't detect any. So they could still be there. Go ahead.
I just had one follow-up on I think it was one of your first slides. You had some fish above the dams in the banana, where you had
Receivers probably.
Receivers.
Yeah. So yeah, I probably borrowed a map from some. It would have been, oh no, it was genetics. It was genetics. So it was the genetics plot. So we did take samples of fish from above the dams because, so that red circle up there, the upper Menominee, because those dams have prevented upstream movement. Downstream movement can still happen, but upstream doesn't. And you'll see that Menominee one's really red, and it's not, but there's a little bit of red here and here, right, too. So, but the upper Menominee is much redder than the lower Menominee. So there could be something going on where maybe you would say the red is like the native resident Menominee River smallmouth, and there's still a little bit of that signature, but now you're getting more of the bay, like a bay signature there. And we have tagged fish in the Menominee upstream, adults, and like very few of them went down, but some did. So there's your avenue for a mixing.
Great program tonight, thank you.
Yep,
Can you
appreciate it.
comment on the state of the population, I mean, compared to like 10 years ago to today? Where does the bass population sit?
So York, I can speak to York County, West Shore, I can't. Go back 10 or 15 years. Back 10 or 15 years, we were in considerably better place. It dropped by, I would say, if you're gonna run an average over all the different populations on the lake and on the bay in Washington Island, by about a third or more. And that's consistent. So it's hard to tease out to say Sawyer Harbor and Little Sturgeon because they get pounded so hard. They've come down tremendously, but so has Washington Island. Washington Island is protected all the way until July. So that's, yeah, some of the stuff that Dan students have done. This work is all integrated into the recent proposal that we made to put a catch and release season on to help try to address that issue. But clearly it's not, or at least not entirely a fishing pressure issue. Something going on around the whole peninsula that's an environmental issue. Or they're just coming down from really, really high numbers and they'll may not ever get back there again. But, that's a harder thing. Yeah, but they've definitely dropped since we had huge years classes in the 90s and throughout the early 2000s, but 2010s were not good for bass recruitment.
Yeah, and I think like the habitat, especially in places like Sawyer and Little Sturgeon, not maybe when the fish are spawning, but after they spawn, the vegetation coverage and the number of largemouth bass and all, you know, they've become like a little bit more of a warm water environment than they were quite a while ago. That could definitely have some influence. Like I was stunned the first time that, you know, I went to one of those Sawyer, like in the middle of summer to go try to find one of our receivers that we put on the ground and I could see it. I mean, it was a forest. And that's not what happens where smallmouth spawn, at least most of the places that I've been. And that's the one thing, like, I think I have a little bit like perspective. I've worked in 5 states. I've worked on Dale Hollow. I've worked on Lake Erie. It's still a pretty amazing place to go fish for smallmouth bass. Like it's one of the best places in the world, like population wise. It's amazing. We were on Eagle the one day when the bass like actually showed up and there were just thousands of smallmouth bass and hundreds of Ned rigs flying in every direction. And it was awesome because none of them were eating Ned rigs. They weren't even interested. They just got there, just showed up, you know. But it was so amazing to see it. And I still think that's pretty incredible, even though the numbers might be down some from previous. I would have loved to have seen it back then. It was probably pretty amazing.
You mentioned the decrease in the numbers the last 10 to 15 years could be due to environmental issues. And I'm wondering what those environmental issues might be.
Well, like Dan brought up, the system,
There you go. It's making sounds now, I
I
think.
think it's this.
Oh,
yeah,
That one down.
so the system has changed considerably, especially in the southern part of the bay. The species assemblage has changed. A lot more warm water fish, like centrarchids, bluegills, pumpkin seeds. Fish like gar have really increased numbers. So things like that have changed. To the north, we have gobies on the waterscape. We have larger swings, what I would expect to be seen. And one of the last talks I've got, if you want to dial it up, was looking at the changes in the overall climatic patterns in these cold water intrusions, for example. And we had folks from, again, going back to how we rely on the federal research agencies. We had a lot of folks from NOAA, from the climate end of things, doing kind of large scale water change temperatures over time, graphs like that. And essentially, the water has warmed on average across the bay about, in the last 50 years, about 3 to 5 degrees. So you're talking about shifts like that, may or may not throw off fish to a certain extent. It's just a wide hard to pinpoint, but things have changed considerably over the last 20 years or 20 to 30 years out here. And you can point to whether it's invasive species, whether it's changes in climatic patterns, whether it's the ecological changes brought on by mussels. So we're really dealing with a very dynamic system that's tough to pinpoint. And I would say all of the above, most likely.
yeah, I think water levels, I mean, they're low, so low.
They've been swinging very wildly.
Right.
And yeah, we're going from highs and lows on a much more frequent basis than we used to. So yeah, pick a card.
So one of the things that we're working on with Scott is from the nesting study that we did, we developed like a method for trying to sample bass when they're this big, age 0 at the end of the summer, because we don't have an early index of how many fish are there from this year. And then we've kept doing it. So with Scott's help, and we go up there and shock a couple nights, we're just going to try to do that over like a 10-year window, 7-year window, and then see if what we caught when they were zeros lets us know how many were there when they were 4 or 5 or 6. And if it correlates well, that means like what's happening to regulate how many there are is probably happening like pretty early in life. It doesn't mean there aren't other things that are happening, but if they're correlated, that means like at that point in time, the year class strength was probably fixed for the most part. And you're looking at the issues that would be affecting it would be things that would affect survival from, say, eggs to into summer, rather than survival from 1-year-old to 3-year-old fish. And it would help us just kind of look into that a little better. Yeah.
Fish around here seemingly
Ulcerative lesions or sores, yeah, that are consistent with largemouth bass virus, and at least the testing that's been done has showed it to be diagnostic here for largemouth. So
if there's anybody on Zoom that wants to ask a question, if you turn off your mute and speak into the microphone, we'll be able to hear you. We'll give you a chance.
as long as it's nobody I know. I thought they were muted for life.
Okay. Not hearing anybody, we got another one up here.
Do you notice any decline in the number of bass as far as recruitment in respect to, say, the last 15 years with the number of tournaments that we have now, where basically in this part of the year, the bay, they're getting all pulled off the beds in the spring versus other areas?
So I wouldn't know the answer. I mean, you might there could be like some kind of correlation there, but that's not cause and effect per se. I mean,
So if we go back 15 years, we probably had less than a quarter of the tournaments that we have now.
yeah, but my fear is there's probably several other things that have changed over 15 years that could also contribute to those changes. So I'm not saying it's not a factor, but you would have to weigh it against like changes in temperature, changes in aquatic vegetation, changes in goby abundance, and 10 other things, a lot of which I think have probably changed in some direction over that same period of time.
Keep in mind, like I said, that Washington Island and Howard Bay have followed this trend from after.
Yeah, there's no term. So there's like some data that to the contrary.
Well, I just noticed that there's a lot more smaller bass from Egg Harbor North than there is from Egg Harbor South.
Yeah.
I'm just gonna ask you, and because I see it more on the water and I don't have all that sophisticated equipment. Bed counts, and we used to do bed counts. And I could tell you for lots of years of experience that inside of the islands in Sawyer Harbor, there would literally be hundreds of beds. There isn't a fourth of that in the whole harbor.
Yeah, correct.
The Flats is the same way. We had a great spot where we used to call the slippery slide. The slide's gone now, but if you remember that yellow slide that came down. And one year, that was the only place they were left there. And we've heard studies that if they get beat up on in a spawning area, the next year they will not come back. We definitely proved that. We went from 50 beds to 0. So a simple thing without a lot of sophisticated equipment, bed counts to me would be an important thing of how many fish we have actually spawning. It would tell us what kind of young of the year we're going to expect that by fall.
Yeah. So how over what time frame did you see that like decline in bed counts, like a decade or?
The next year there was
fewer.
We used to do a lot of bed counts on the flats.
Yeah.
And we don't anymore. And I think there's probably numbers. So
yeah.
But that north end that had so many beds, I mean, you got to look real hard to find one of them.
Yeah. So I think that could be indicative of how many nesting males you have. And I think it going down, if it was 1 year to the next, that's different than like over time. Because if it was just going down over time, it would be indicative of the fish population dropping. The one thing though that like we showed from Eric's stuff is that peak nest frequency and like nesting success are not great predictors of like how many age 0 bass are going to be in that harbor at the end of the summer. I call it they're an imperfect predictor. Like sometimes it works, but there's cases where like in Sawyer and Little Sturgeon, we saw pretty big differences in nest success. But there was only 1 year in Little Sturgeon where we caught like all kinds of age 0 fish. It was like 42 an hour. And then across all the other bays, regardless of nest success, it was like 12 or under was the catch rate per hour. And there, so it's like nest success, the percentage of nests that produce fry didn't correlate to like how many age 0 fish we caught there.
I guess I'd have to say though, because I heard the same thing with the walleye one. There's probably a percentage across the board of how many eggs are going to turn into a fingerling.
Sure. Yeah.
And it just makes mathematical sense that if you had twice as many spawning, there would probably be twice as many young fish. Is that anywhere near true or not?
Nah.
I mean, Mother Nature can do what she wants with the eggs.
Yeah. If you look at
when you have a lot less beds than what we used to have, the young of the year counts have to be less.
Not if there's density dependence through the rest of the summer. You can actually have more bass and end up with fewer bass. If there's too many of them and they're competing for the same resources, you can go from having tons of age 0s, and by the end of the summer, that year class doesn't look any different than a year class that only hatched half as many fish. So most of the time that you look at like relationships between number of parents and number of offspring, it's not a line. It's not more is always more. Yeah.
It's just hard for me to comprehend.
But it's the same in your garden. If you plant too many carrots, do you get? It's no different than anything else. Like people just, you can only have so many in that space. So if you overshoot that, eventually it's just going to come back down to the level that that space can maintain. So you could hatch a whole bunch, but you're still going to end up at some level that the habitat will support. Yeah.
But aren't you also saying that the habitat isn't?
Well, it's different. The habitat is different than it was. But yeah, that's like the hardest thing for people to grasp is that how many hatch may not be how many you get at the end of the summer, and like all these other factors play into it. Big year classes as larvae might not be big year classes at the end of the summer. Because things happen, you know, there's not enough zooplankton. They hatch a whole bunch of fry and there's not enough zooplankton for them all. And you have a 90% mortality rate, but in another year you hatch half as many and the survival rate is higher, so you end up with the same number at the end of the year. Yeah, it's hard to explain maybe. Sure.
And just the fish that are caught, like, you know, it's amazing to me that 76% return way up, you know, the 27 miles. Is that what you said?
Yeah, yeah.
Return. So is it kind of along the same lines, the behavior of letting the salmon go in Strawberry Creek, they imprint where they were spawned and that's where they return to?
So
what, you know, if I caught a fish on the flats and took it back to be weighed in a tournament or whatever, it's gonna go right back to the flats and not keep going. You know what I'm saying?
Yeah.
What I'm asking?
So with salmon, like finding their home river, we know that, or we at least think, we can't ask them, that it's like olfaction. They detect like trace elements in the water that's unique to that river. I can't believe the flats is any different than right around the corner in terms of the, like what's in the water. So I think there's got to be something else to it.
Over 30 miles.
I would love to know. Yeah. That's what people are like, well, why don't you just put them on the truck and drive them? Like, well, maybe that messes them up. I don't know how they know, so I don't want to do something like, it's already crazy to put them on the back of a boat and drive them somewhere, but they somehow know. So now if somebody has lots of money, we could do it and put them on the truck and see if they still do it. Because then they wouldn't have followed like the path that they would have to follow back. It would be some crazy.
Wow. Well, that's
Yeah. Or maybe we should like drive them out in the bay and drive them around in circles for a while. Because in a tournament they probably do that. Yeah.
Early in the Sturgeon Bay Open, we tagged fish in 4 different locations, A, B, C, and D. And those fish were brought back to that particular spot. Little Sturgeon was one, Egg Harbor, the Flats was one, and one right by the launching ramp. And those fish, we found A's and D and D's and A, and they did not all go back to where they were.
Yeah.
That was, that was definitely done with tagging from a location.
Yeah.
The interesting thing is we had one fish that was released somewhere after the 3 o'clock first weigh-in. It was the first one or second one, I'm not sure. At 5 o'clock, it was caught in Sawyer Harbor, and it gained a pound.
And so when you tagged them, were those like during spawning? Okay. Okay.
Does the flowage of the water affect populations in any form of way?
Sure. I mean, it makes a big difference. It's probably a cue in the rivers. Like if if flows aren't appropriate, the fish may not have that cue to enter the system. Like it's got to be at a certain level. And in a river, if it gets too high, especially for something like a bass, you're probably going to destroy a bunch of nests, and it wouldn't be good for hatching success or things like that. But even out in the bay, like there's currents moving around all the time, and that can dictate like where plankton ends up. And if things aren't the same, maybe a place that hatches a lot of bass isn't getting as much plankton sort of delivered to it as it does in other years. And so they don't do as well if the currents shift around. But in the rivers, it's like flow is the thing that regulates everything in a river, really, for fish, and temperature. Temperature always matters.
So I think there's a reason why he leads in the number of presentations. You can see he really knows his stuff.
Oh.
And actually, in terms of, I was kidding him about the researcher asking for more money. One advantage of the co-op program is that typically his salary is covered by the federal government, so you don't need to make that up in grants and so on. So that's a very big benefit. In fact, to be honest with you, when I found out that the research stations and the co-op stations were funded, I knew that Tammy Baldwin and Tony Weed both voted for that, so I wrote them a letter and said thank you. Because they need to know that science and research matters for our fishers here in the Reed Lakes. So, one big round of applause.
Thank you.
And all for someone else next year.
Thank you.
No problem. Thanks for coming.
Thank you, Michael.
I did. It's right there. You want to show me? I'm going to, can I close the Zoom?
Yeah.